Hello, this is Himanshu Nigam from IIPS and DDVV University, and here I am explaining the comparison of iterative methods. Here we compare 5 methods which are bisection method, false position method, Newton-Raphson method, secant method and successive approximation method. On the basis of iterative formula, their order of convergence, evaluation of functions per iteration, and reliability of convergence. Here the main basis of comparison of the various iterative methods presented in this table are the rate of convergence, the amount of computational effort per iteration, and the sensitivity of the method to the starting value and the intermediate values. Let us begin with the first method, which is our bisection method. The iterative formula of bisection method is xi plus 1 is equals to xi plus xi minus 1 divided by 2, where the root lies between xi and xi minus 1. Order of convergence is gain of 1 bit per iteration. That means every iteration bring closer towards our root of the equation. Now it is one function which is evaluated per iteration and there is a guaranteed convergence. The bisection method converges slowly. It is, however, the simplest iterative method and is guaranteed to converge. Convergence is slow and steady. Now next method is false position method, where the iterative formula is xi plus 1 is equals to xi minus 1 fi minus xi into fi minus 1 divided by fi minus 1, where the root also lies between xi and xi minus 1. Here the order of convergence is 1 and there is one function which is evaluated per iteration. Here is also guaranteed convergence. Now, the false position method is guaranteed to converge. It is, however, slow as it is first order convergent. The amount of computational effort per iteration is one function evaluation. It is not necessarily monotonic convergence to the root, but most often it will be superior to bisection method. Now our next method is Newton-Raphson method, in which the iterative formula is xi plus 1 is equals to xi minus f of xi divided by f dash xi. Here the order of convergence is 2 and there are two functions which is evaluated per iteration. Here the convergence is fast if starting point near the root. Now in the Newton-Raphson method, it has the fastest convergence among all. It is an excellent method if one is ready near the root. It is, however, quite sensitive as it may diverge if f dash x is near 0 any time during the iterative cycle. Besides this, the amount of computational effort required in computing the values of fx and f dash x is considerable and the overall computing time may be large in spite of the inherently high rate of convergence. Now our next method is secant method, where the iterative formula is xi plus 1 is equals to xi minus 1 into fi minus xi into fi minus 1 divided by fi minus 1, where it is not necessary that the root lies between xi and xi minus 1. Here the order of convergence is 1.62 and the evaluation of function per iteration is 1. Here is no guarantee of convergence if not near the root. Now in the secant method, The second method is not guaranteed to converge. It, however, converges faster than the false position method. The order of convergence is 1.62 here. It also computes the given function only once per iteration. It may be considered the most economical method, giving reasonably rapid convergence at a low cost. Now, our last method is successive approximation method. Here, the iterative formula is xi is equals to g of xi minus 1. Here, the order of convergence is 1 and there is one function that is evaluated per iteration, and here there is no guarantee of convergence. The successive approximation method is suitable in some special cases. It is easy to program and is first order convergent. It is not guaranteed to converge. So that's all about the comparison of iterative methods. Thank you.